So whenever we talk about cars, there is a word that usually does not miss out in the topic, and that is the word horsepower. So the question is, what is this horsepower? What is it all about? In fact, when you come to think of it, horsepower is one of those things that a good number of customers take into consideration before purchasing a vehicle. Okay, so of course, the main thing that I want to try to understand in this video is what's the difference between crank horsepower and wheel horsepower. But of course, it's important that before we even go as far as that, let's try to understand what horsepower is in general itself. What is horsepower? So the most basic definition for horsepower that I can ever give is actually that horsepower is just a figure. It's just a figure, it's just a value that indicates the measure of power of an engine. It actually shows how much work that particular engine is capable of doing. That is what horsepower is. I feel nothing more, nothing less. It's as simple as that. That is what horsepower is. It's power, of course, but we indicate it as horsepower. Okay, so how we determine horsepower of a vehicle is what is used. The machine that is used is called a dyno machine. There might be other methods, but there might be other methods, but I'm not sure. What I know is that we use the dyno machine. Okay, so of course, when you buy a vehicle, you don't need to go to a dyno machine to determine what the horsepower is. When you buy a new vehicle, the details about the horsepower of that vehicle is going to be given. But let's say you were working on an engine, okay? You were tuning an engine. You want to now find out what the value is of the horsepower that you now have after working on the engine. A dyno machine is what is used, and of course, it all depends on the drivetrain of the vehicle that you are dealing with. It all depends whether it's like it's an all-wheel drive, okay, an all-wheel drive, or maybe it's a four-wheel drive, or maybe it's a front-wheel drive, or maybe it's a rear wheel drive. Okay, so it all depends on the drivetrain. So whenever you see these on a vehicle, okay, you can never see all of them at once. I don't think that even makes sense. Each vehicle is either it's an all-wheel drive, four-wheel drive, front-wheel drive, or rear-wheel drive. So these here, these those letters, they just indicate the drivetrain. They just tell you the drivetrain of that particular vehicle. When you see 4WD, just not to say that vehicle that you are seeing is it's a four-wheel drive. Okay, so now, before we even go into details about the dyno, calculating the horsepower, so on and so forth, let's answer the big question, which is actually the main reason for this video. That is, what is the difference between crank horsepower and wheel horsepower? What are we able to understand from the definition point of view or the theoretical point of view, and what are we able to, how are we able to how are we able to view that in terms of like an actual something that is actually working? Like, I have this picture here that is going to help us a lot. So when talking about crank horsepower is just nothing but the pure power output from an engine before mechanical losses. So before any mechanical losses, this actually happens at the engine itself. That's why you're going to have crank horsepower. That is a pure power output from an engine before any mechanical losses. So what it is that I'm going to take this as, let me take this as a rear wheel drive. Okay, this might be an all-wheel drive. Yeah, this might be an all-wheel drive, but I'm going to take it as a rear wheel drive just for this example. So so what it is that at the engine here we're going to have crank horsepower, which is a pure power output from an engine. Then when talking about wheel horsepower, this is just the total power after mechanical losses. So after mechanical losses, you're going to have wheel horsepower. So the wheel horsepower is determined from the wheels themselves. So you observe to say for these wheels to have rotation, okay, we have this drive shaft here. Okay, we have this drive shaft. Then at this point, you're going to, here we have the transmission, sorry. Okay, so we have the engine here. So after all the mechanical losses in the transmission here, as well as the drivetrain. So like the drivetrain itself, or like this whole entire part here. Okay, after we have all those mechanical losses, because what transmits these rotations is that what is used are gears. Okay, so it's obvious there are going to be mechanical losses. There's going to be some power or some energy that's going to be lost. It might be due to friction. Okay, and yeah, it might be due to friction and some other reasons. So after all those mechanical losses, you're going to have horsepower at the wheels, which is determined using a dyno. Okay, so what it is when you're talking about a dyno is that these wheels, they're going to be placed on some kind of like a cylinder kind of thing, and they're going to be rotating. And as they are rotating, okay, from that rotation we'll be able to determine what the horsepower is. And that horsepower, we determine it from the what, from the rpm, which is the revolution per minute, as well as the torque, as the torque. So when you multiply the rpm by the torque, then we divide by what, we divide by a constant, which is 5252. This gives us what, this gives us horsepower. Okay, so that's actually how we get the the horsepower. So here is what really happens. So let's say this is a real wheel drive, of course. So what you have here at this point, this is a dyno. Okay, sometimes you find that there's only one kind of like one wheel that's placed at this point, then you have this wheel that is rotating, then from there we do the calculations. So what it is that uh, this vehicle is going to be supported in some way, so that it doesn't move out of this position that is being put, whereby the wheel is touching this wheel here and this one here. These are just more like cylinders that are rotating. So from those we get values such as the torque, rpm, so on and so forth. But of course, in general, when talking about a dyno does not really directly calculate horsepower. It just gets the torque, um, it just gets the torque, the time, and the rpm. So that's what the dyno gets actually. So from that, the calculations are made, then we get the value of the horsepower. But of course, this is the formula that is used for the horsepower. So this constant here, how it's gotten is this way. So when you come to think of it, horsepower is just nothing but power. So power in itself, power, I'm just going to indicate it as p. Power is just equals to what, power is just equals to force multiplied by what, multiplied by velocity in this case. Okay, so we should also remember to set torque, which is, I'm going to indicate it as t, or let me indicate it as something that appears more like that. So torque, you're going to say this is going to be equals to force, force multiplied by what, multiplied by radius. So what do I mean by radius? Okay, so it's just more like you have a wheel. Okay, we have a wheel, then you have a center there, and from that center to that circumference there, we have the radius. Then the torque that you're going to have is going to be the force multiplied by what, multiplied by the radius. Okay, so from that, let's say we also have velocity. So we understand to say a vehicle is going to be moving in a particular direction. Velocity is just going to be equals to the distance divided by what, distance divided by time. But because I'm talking about wheels, where I have velocity here, you know that a wheel is just like it's a circle, of which I can say that is just going to be 2 pi r. It's more like the circumference of that circle. I'm going to multiply by the rpm. Okay, rpm, then this is going to be equals to d over what, d over t, like that. So now here I have my velocity, so it's like my d over t is my velocity. I can substitute. Okay, I can substitute there. Then for the force, I can say force, now force is going to be equals to the torque divided by what, divided by the radius. So I can come and say my power is going to be equals to the force. I found that is the torque divided by r multiplied by the velocity in this case, which is the d over t, which is just going to be 2 pi r by what? RPM. Just get rid of that. By RPM. RP RPM, revolutions per minute. So you observe to say this radius is going to cancel out. So I'm going to remain with, I'll say my P is going to be equals to the torque multiplied by 2 pi multiplied by revolutions per minute. Okay, so I'll divide this by, are you going to divide this by anything? No, not for now. So to convert this to horsepower, there's a constant, there's a conversion that we are supposed to use. So this was actually done by, this was actually done somewhere in the 18th century by a Scotland inventor by the name of James Watt. So somehow by a series of experiments, he roughly came up with something that indicated that 1 horsepower, okay, 1 horsepower, which is 1 HP, is going to be equals to what? 33,000 uh 33,000 foot pound per minute. Okay, pound per minute, pounds per minute, I would say per mean there, per minute, like that. So what it means is that for us to get to horsepower is, we are just simply going to say horsepower. For us to get horsepower is that we're going to say horsepower is just going to be equals to this here, the torque by 2 pi, 2 pi by RPM. Okay, RPM. Then we're going to divide this by what? The 33,000. Okay, so now you observe to say, we can say, we know what pi is, so we can say this into 2 pi into 2 pi is a 1, then 2 pi into 3000, I mean 2 pi into 33,000 is roughly 5252. That's where the torque by revolution per minute, divide by what? Divide by, sorry, this is supposed to be 2, by 5252, like that. That's how we come up with what? That's how we come up with the horsepower. So it's just a torque multiplied by the revolutions per minute divided by that value. That is going to give us the, that's going to give us the horsepower. And of course this is seen in terms of like a dyno graph, which is more like this, where you have the y-axis and the x-axis, like that. So let's say we have something like, let's say we have that, we have the horsepower curve, like that. Okay, then here maybe from this point you have what? You have the, let me indicate it using a different color. So from that point, maybe say you have the torque. Okay, so at this point where they meet, you're going to have a what? That's where you have the value, which is what? 5252. Okay, so of course this is subject to changing in terms of like the value that you're going to have here. This is subject to change. It depends on the units, I mean the scale that you are using on the what, on the y-axis there. But either ways, that's how we determine the horsepower, and that's the difference between crank horsepower and wheel horsepower. Crank horsepower is just a pure power from an engine. Wheel horsepower is just a like the final power that you have after some mechanical losses. So crank horsepower is before mechanical losses, wheel horsepower is before mechanical, sorry, crank horsepower is before mechanical losses, wheel horsepower is after mechanical losses. That's actually the main difference between those two. So that's all in this video. Thank you very much for watching.